This topic is about factoring because in calculus, you're going to often need to solve an equation which will require factoring. Also, you're going to have to compute something called a limit that will again require factoring, and I'm sure other reasons as well. So let me give you kind of my view of how you factor. You're going to go through an order and say, okay, the first thing I'm going to look for is a common factor, meaning what is just something you can pull out that's common to everything. That is always going to be what you want to look at first before you do anything else. I'll look at some examples in a bit, but next, let me go ahead and say the next thing I would check for is a formula. There aren't a whole lot of these. The only one really that I would say you definitely need to memorize before you go into calculus is the difference of two squareds formula. It's also a good idea to memorize a few other formulas like the sum of two cubes and the difference of two cubes, but they're nowhere near as important. And then the next thing I would say if you can't find a formula is what I call the double bubble. Now this is actually what most people refer to when they think of factoring. This is where you draw those two parentheses, you find two numbers that multiply to give you something and add to give you something else. Well, we'll go over that in just a bit, but that's what I call the double bubble. And then if that fails, the next option I would check for is AC. Now this AC method is one that I wish people taught more. It basically is what happens when double bubble fails, but you still have something that's factorable. Some teachers teach to just do guess and check, and I never like guess and check. So I'm going to show you a better way to factor using that. And then if that fails, you can still try grouping. Now, AC and grouping are kind of together. AC actually is a way to turn it into grouping. So I'm going to talk about those together. But these are the ways that we factor. So now we've talked about that. Let's look at some examples, and I'll try to do some of each of these. For our first example, let's look at 2x squared plus 4x and try and factor this. Now, this is a great example of a common factoring because you'll notice that 2x squared, well, if you factor that, find all the common factors, well, there's a 2 and an x and an x. Those are all the factors. For the second part, we have a 4, which is a 2 times 2, and an x. And so you'll notice there are some common things. There's a 2x, let's use a different color here, 2x in both of them. So since it's common in both, you can factor it out, which is actually just division. When you pull it out, divide each of these terms by whatever you pulled out. So the 2x squared divided by 2x is just an x left over. Or just look at, the one thing left over. And then when we take 4x and divide by that 2x that we're pulling out, well, we're left with just this one thing here, 2. So this thing factors by common factoring, which if you ask me is the easiest one. That's how I have it on first in the list. Always do it if you can. Is 2x times x plus 2. So we have now factored this, which is very useful, as I mentioned, for solving equations. Like if this were equal to 0, we would take it another step. And for that, there's another video about how to do that. But for now, we're done with that factoring. So let's take a look at another example. Here we have a quadratic, x squared minus x minus 2. Now, this looks like it kind of falls into the more classical what you picture when you learn factoring. It's basically something like this. But I would still look at it first and say, okay, can we do a common factor? And the answer to that is no, because the first term only has an x in it. Those are the only factors is x and x. But the last term doesn't have an x. So we can't do common factoring. But I still recommend that you look at it because it's very, very important and easy. The next step we look at is a formula. Well, I think the only one we can really talk about right now that we know is the difference of two squareds, and well, this is not the difference of two squareds. We will talk about that in a moment, but this is not just taking something squared minus something squared. So that brings us to double bubble, which I think we expected because this is a typical factoring thing. So we're going to end up with double bubble. So when you do the double bubble, you just put parenthesis, parenthesis, x and x. You always start off the same way. But then we want to find two numbers that multiply to give you 2 and add to give you 1. So what I like to do is just write the 2, and I like to ignore the negatives until the end. They are very important, but I'll ignore it until the end. And just think, okay, how can I multiply two numbers to get 2? Well, there's only one option, 1 and 2. And then after I figure that out, now I'm going to consider the negative and say, well, because this number is negative, two numbers that multiply together to get negative means only one of them is negative. So one of these two has to be negative, and which one will be determined by this sign here. because when I add them together, I want to get -1, a negative. So let's make the bigger one negative. So we'll put the negative on the 2. So we found we want 1 and -2. So we just say +1 and -2. And that's it. Now, you might ask correctly, and if you don't know the answer to this, please pay attention because you should. You might ask, why did we do that? Why did we find two numbers that multiply to give you -2 and add to give you -1? Why would we care? And the answer to that is if we were to FOIL this out. So FOIL means let's do first, outside, inside, last. We're just going to simplify basically is what that is. So the first is x times x, that's x squared. And if we were to do the next part, that's x times -2, so minus 2x. And then the inside is 1 times x is plus 1x. And then the last is 1 times -2, so minus 2. Now if I simplify these, we have x squared. And then these two terms in the middle here are common terms. -2 plus 1 is -1. And then minus 2. Now if you look at what we did there, it should pop out, right? Why did we look for two numbers that multiply to give you -2? It's because in this blue one right here, we took 1 and -2, and that's where we got that 2. Also, why did we look for the numbers that add to give you a -1? That's because of this middle term here. We add the -2 plus the 1, and that's what gives us, in the end, this -1. So that gives you a little bit of why we do the double bubble the way we do. All right, let's take a look at another example. Here we have 6x squared plus x minus 1. Now you might think this looks like a double bubble. But let's start off and say, okay, common factoring, nope, that failed. Formula, nope, that failed. Double bubble. Double bubble, if you ask me, requires that you have x squared only has a 1 in front of it. So this 6 means we can't do the double bubble. Now here's where I might disagree with what your teacher taught you, because it is possible to go ahead and say, oh, well, let's take a guess and check approach and say, okay, how about 3x, 2x, 1, and 1? You can do a guess and check approach. But I never like guess and check in math. I will always try and find a way to avoid that. So I'm not even going to show that here. But if you want to do the guess and check approach, go ahead. But what I'm going to do is say double bubble has to have the leading coefficient here, a 1. So double bubble failed. That leads us to the AC method. Now the AC method basically is for things that you would think it's double bubble, but hey, the leading coefficient isn't 1. So what I'm going to do is I'm going to multiply A times C, thus the AC, right? Remember, if you have ax squared plus bx plus c, that's where the AC name comes from. I'm going to multiply A and C. So that gives me 6 times -1 is -6. Now I'm going to pretend for a minute that we did have a double bubble and we were going to factor x squared plus x minus 6. I just replaced this last number with this one. We're pretending this isn't quite right. Let's not really do that. But that's what we're going to be thinking of. So we want two numbers that multiply to give you -6 and add to give you 1. So that's going to be 3 and 2 that differ by 1. We have to have a negative for the -1, so one of them's negative. And they have to add to give you a positive number, so let's this time make the smaller number negative. So 3 and -2. Now, instead of doing the double bubble with that, though, we're going to take that information and do something different. We're going to take this thing, specifically the middle term, and change it. So we have 6x squared plus x. But if you remember, the 1 can be rewritten as 3 plus minus 2. So let's do that. We have 3x minus 2x. We broke it up in a very specific way to make this work, minus 1. We just replaced this x with 3x minus 2x. And we know that'll work because, hey, we looked for two numbers that makes that work. Now, let's do grouping. So I'm going to kind of teach grouping now, because grouping is where you basically probably have 4 terms, and you just take the first 2 and the last 2 completely separately. So I'm just going to factor the first 2. So we go back to the beginning of our factoring list and say, okay, can we factor out a common factor? And yes, we can. We can pull out a 3 and an x. We're left with a 2x out of the 6x squared. And, well, we pulled everything out of the 3x, so just plus 1. Then for the next part, here, let's be careful because we can pull out a negative. And I would advise, if you can pull out a negative, you should, if you see a negative in front of the highest power. So I'm going to pull out a negative, and that's really all I can pull out. But I have 2x and then a plus 1 because I pulled a negative out of both parts. Now here's where you hope you got lucky. if you were dealing with grouping, if you're dealing with AC, you should get this, otherwise you did something wrong, is that these two things should be the same. And if they are, well, let's just go ahead and do common factoring again. We can pull out that 2x plus 1 as if its own thing. And we're left with the 3x in the first part and a minus 1 in the last part. So now we have factored this. That is what I call AC factoring, which also incorporated knowing how to do grouping as well. Okay, I have one more example to do for factoring. Here we have something a little bit different than we've done in the last examples. We have x squared minus 4, and it's equal to 0. So because it's equal to 0, we want to take it a step further. We don't just want to factor, we want to solve. Now, I want to point out, you don't actually have to factor to solve this, right? You could just add 4, get x squared equals 4, so x is the square root of 4, so plus or minus 2. Done. Okay, but hey, we're trying to learn how to factor. So let's actually solve this by factoring instead. So let's undo that. And so if we're going to factor this, we start off again by common factoring. Always start with common. Well, it failed this time. It didn't work. And in most of my examples, common factoring doesn't really work. But please remember to do it, because you might very well get to the point where you spend a lot of time trying to factor something that, well, could have just been common factoring. So we go on to the next one, which is a formula. Well, now we do have a formula, because this is the difference of two squareds. We have something squared, x, minus something else squared, which is 2. So we can factor that. So that factors into x minus 2 times x plus 2. Now, if you don't know the difference of two squareds formula, I'll give it to you now. If you have a squared minus b squared, that will always factor into a minus b times a plus b. So in our case right here, a is x and b is 2. So we just have x minus 2 and x plus 2. And then that's equal to 0. We're done factoring. Well, we're not done solving it. We're not done with the problem, but we're done factoring. Now we just have to say, okay, well, the only way these can be equal to 0 is if this one's 0 or this one's 0. So if x minus 2 is equal to 0, we'll add 2 to get x equals 2. And if x plus 2 is equal to 0, we'll subtract 2 to get negative 2. Hey, that's the same thing we got before. Which is what's really nice about math, is you can do it all sorts of different ways, and you should still get the same answer. If you don't, well, you made a mistake.